Alright guys, we're back again here to on episode 2 of our steam engine series in Solidworks. So, last episode we began modeling some of the simpler parts. If we come take a look real quick, we will see that we got the first 4 parts completed in this series. So what we're going to start on now is one of the more complicated parts involved in the assembly. Now this is going to be the base of the steam engine. So here, in case you didn't catch the first episode, this is what we are working on modeling by doing each individual part one at a time, and then in the end assembling them all. So this is what I have in store for you this episode. This is the base of the steam engine, and as you can see, this is one of the most intricate parts involved in this assembly. In fact, it's probably the most intricate part, with multiple different boss extrudes, several different cuts and slots, fillets all over the place, holes all over the top of the part. This will certainly be a very entertaining part to model in SolidWorks. So, how are we going to do it? Well, first off, we are going to start by modeling the main structure of the part. So, we're going to look at our drawing and look at the dimensions, and we're going to figure out what the overall dimensions of the main body are. So we can see here that this piece is 156 millimeters wide here to here, and 174 millimeters deep here to here. So what we're going to do is we're going to go ahead and create our new part in SolidWorks. Once that new part comes up, we're going to do a sketch on the top plane. We're going to use center rectangles. I believe I discussed the usage of center rectangles in the last episode, and that they give you plenty of control over reflecting different features across planes later on in the development of the part. So we're going to set that to 156 by 174 millimeters. That will be the main body of our part. And actually, first, let's go back to that sketch. Notice that we have some chamfers along the edges here in this part. So what we're going to do is we're going to go ahead and do those chamfers in the sketch. We notice those are 3 millimeters deep by 45 degrees. So if we come to sketch, sketch chamfer, and we select these 4 edges, change this to 3 millimeters, and oh well, it did not change all of these. Let's just go through and change each of these to 3 millimeters. Alright, now we can do our extrude, and we notice that according to the drawings that the overall depth of this part is going to be, looks like 45 and 6, so 51 millimeters deep overall. Go ahead and do that. Alright, now we have the main body of our part. So the next thing that we are going to want to do is to create the slots in the side of the part here. A series of 4 slots on each side. So if we look at our part, we notice that those slots are on the long side of the part, for one. We also notice a couple measurements pertaining to these slots. We notice that they're centered on the part, and that they are 8 millimeters apart from each other on each side. And we don't have dimensions for the exact widths of the slots, but we notice that the entire part is 174 millimeters wide, with separations of 8 millimeters on either side of each of them. That's 24 millimeters altogether. Leaves 150 millimeters for these two cutouts, meaning that each of them are 75 millimeters wide. So they're each 75 millimeters wide, and also according to the sketch, excuse me, they are 20 millimeters deep. So 75 millimeters wide, 20 millimeters deep, and if we come also right here, we notice that they are 22 millimeters tall, and that is 15 millimeters from the bottom of the part. So let's go ahead and start a sketch on the side of the part. Use a center rectangle once again. And those were 75 millimeters wide by 22 millimeters deep. Set 15 millimeters from the bottom and 8 millimeters from the side. Now we can go ahead and draw a center line here. We come up to mirror entities, select this rectangle that we just drew, and select that center line as well. We can reflect that sketch over that center line. Now, there are also some chamfers involved in this part and in this cutout, and we notice those chamfers are in fact of radius 4 around the entirety of the part. So we can go ahead, and actually those are fillets, my bad, because those are rounded. And we notice those are 4 millimeters radius, so we can go ahead and insert those fillets while in the sketch so that we don't have to worry about doing it to the part after we've done the extruded cut. So now that that's done, we go ahead and do our cut, and we saw that the cut was 20 millimeters deep. So if we go ahead and do that, we now have 20 millimeter cut extrude to the side of our part. Now, lastly, what we want to do is we want to come here, and because we used a center rectangle to sketch the main body of this part, we can select the front plane, mirror, and we can mirror this cut extrude across that front plane. So now we have those slots on both sides of the part. Last thing we have to do is create these 4 millimeter fillets on the inside of the slots. So if we come to fillet, make sure that we set our radius to 4 millimeters, and just select one edge of the inside of this part. Solidworks will automatically select the adjacent edges for you. So there they are. The first step in this main base is done. So now we have those two slots. Let's go ahead and take care of the two longer slots on the other sides of the parts. So we notice that according to the dimensions here, those slots are 20 millimeters tall. They also have fillets of radius of 4 millimeters. They're 10 millimeters deep. And now if we come up here, we notice that there's a spacing of 23 millimeters from each side of the part to that slot. So let's go ahead and start another sketch. And also, one last thing. We notice that these slots are 8 millimeters from the bottom of the part. So, and actually, excuse me, there is something we must watch out for. There's a cut extrude in the bottom of this part. And we need to make sure that that 8 millimeters is indeed from the bottom of the part, which it actually is not. If you notice, that 8 millimeters does not go all the way to the bottom, such as where this 51 goes. But instead, we must add the depth of that indentation, which is 3, to that 8 millimeters. So this slot is actually set 12 millimeters off the bottom of the part. So go into our sketch on the front and use a center rectangle once again. And set this is 23 millimeters from each side. Go ahead and do that. This is, how deep was it? It's 20 millimeters deep. So 20 and 12 millimeters from the bottom, and also with fillets of radius 4 around the entire edge of the slot. So there we go. Now if we get up there, do an extruded cut, and this one was instead only 10 millimeters deep. We will once again do the same thing with mirroring over the center plane. Go and select that cut extrude. There we go. And lastly, we will use our 4 millimeter fillets on the inside edges there. So now those slots are done. Alright, next we're going to move on and do these extrusions on the side for these mounting holes. So we notice there's a radius 15 circle, as well as a radius of semicircle, with a radius 13 circle in the middle, with radius 9 fillets on the edge of those flanges. We also notice that these holes are 186 millimeters apart, centered on the part, and that these holes in this direction are 100 millimeters apart, centered once again on the part. So let's go into our bottom plane here and begin a sketch from the top. Alright, and we notice that those edges are on the longer sides of the part. So we're going to go ahead and draw a 13 millimeter circle here, 13 millimeter circle here. We know that these two are 100 millimeters apart. Let's go ahead and dimension those. Alright, and we also know that these are centered here, which means this would be 50 millimeters. We know that they are 186 millimeters apart in this direction, so we know that the distance to the center would be 186 divided by 2. There we go. We now have the positioning for each one of those center circles. Now, what we must do next is to draw a radius, or yes, a radius 15 circle outside of those, and take two tangent lines down to the surface here. Alright, now we're going to trim away these entities. Alright, and one last thing we're going to do is draw a line along here, trim out the center portion, go to fillet, make that 9 millimeter radius. You can go ahead and apply these two fillets here. Once done with those, trim off the excess on the end and cap them there. Alright, and we can now get rid of this circle, create a center line here. Oh, my bad, that actually was not parallel to the axes. Alright, and now if we go to mirror entities, select this portion, mirror it about here. We now have the sketch for those extrusions made. If we do extruded boss faces, make sure they're going in the right direction. And we notice, according to our drawings, that these tabs are 15 millimeters deep. So I'm going to go ahead and make sure that's 15. Alright, and just as we did with all these slots, we are going to select the appropriate plane and mirror this feature to the other side, just like so. And as we can see, this part is already starting to take shape. So now we have these slots and the sides done. We have these holding tabs done. Next, what we need to do is focus on these indentions in the top. So in order to get those holes, those indentions in the center of the part, we need to look at the dimensions that are given. We notice that each of those holes in the center are 50 millimeters wide. We also notice that the top holes, which you notice aren't quite as long as the bottom ones, are 74 millimeters long. So 74, 50 millimeters, and we also notice that they have radius 10 fillets on each of the corners. And lastly, we know that they go through the entirety of the part. So I'll start a sketch on the top of the part. Go to top view. Well, go to a top view, and those slots run this way from one extrude to the other. You're going to smart dimension those, as they're 74, 50 millimeters. Alright, and another thing we need is the placement of those slots. According to the drawings, we see that excuse me, we see that each of these is located between 26 divided by 2 is 13. So we see plus 6. We see each of these is 19 millimeters from the center of the piece this direction, and they're obviously centered on the piece this direction. So come to Smart Dimension. We go to here. We set this to 19 millimeters. The other way that we could have seen this is by noticing that they are 18 millimeters from the outer edge. So from here, this will overdefine the sketch, but just to show you, there, they are 18 millimeters from the outer edge. Excuse me. So, lastly, we need these to be, we need this to be centered, oh, my bad, wrong direction. We need this to be centered in this direction on the parts, which is Smart Dimension to 0 there. And lastly, we need a similar rectangle on the other side of the part, so we will just real quick mirror these entities across the center line here to get a similar one. Also, I should have done this before I did the mirroring, but these holes are also filleted, so we need to make sure that we fillet each one of the corners, radius 10. Alright, now that's done, we can come back out, do our extruded cut, and just say through all. Shouldn't have any interference there. There, the part is now coming together quite nicely. So, we have these slightly larger extrusions up from the bottom side of the part. So let's go ahead and create a sketch on the bottom of the part, the bottom view as well. And we can go ahead and draw out all of our rectangles, 50 millimeters wide, and we notice that these elongated slots are 100 millimeters long instead of 74 like the previous ones. So they are 100 long. They're the same, the same distance here to here. Oh, that was incorrect as well. The origin to here is 19 millimeters. As you see, that lines them up, and they were centered in this direction. Alright, and something that changes is the radius of the fillet on these. Instead of 10 millimeters, these fillets are 4 millimeters in radius. Alright, and we'll use our center line tool to sketch a center line, and then mirror these entities across that center line. And whoops, it appears that I clicked the X instead of the check mark for those fillets, so let's redo those quickly. Alright, now those are done, we can come out and check on our depth for those extrusions. So, excuse me, we notice that these larger extrusions, looking over here at these dimensions, we can see that it should be 45 millimeters in to here, and there should be a way for us to determine the height of those. Yes, here we go. Here they are. So we see here that these lower extrude cuts should be 35 millimeters deep instead of through all. So we come to Features, Extrude Cut, and we go 35 millimeters deep. That should get us those shallower extrusions, and that looks correct. One last thing that we need to do, there are also fillets of radius 4 on the underside in these sections as well as shown in the drawing, so we will apply those manually real quick. Alright, now we have our center holes for the part. One more thing, which is kind of hidden here, especially in the render. There's another slot from the bottom side, which we can see in the side view and this top view, which is hidden in the render, which comes up inside of that centerpiece. And if we look here, we can see that that slot is a 30 millimeter deep extrusion, which is 26 millimeters wide. And looking over here at this dimension, at this drawing, we may also determine the depth of that slot. We see that it is aligned with the two extrusions that we just made, which were 100 millimeters long. So 100 by 26 millimeters and 30 millimeters deep, and that is centered on this centerpiece here. So let's do one more sketch on the bottom, get bottom view, and this slot will be centered. So if we just start from the origin, make it 100 millimeters by 26 millimeters, and there is felting on this as well of radius 4 on each of the corners. However, there will not be felting. Actually, there will be felting on the top, just like on the other ones. So if we go ahead and click check, do our extrude cut to 30 millimeters deep, and we can then go and add in our fillets on the top edge of radius 4 millimeters. Alright, we're getting rather close to being done with this part. A few more things that we need to do. We need to make the cutouts for each of these tabs on the top. Now, this block that we made initially allowed for the height of those tabs, so what we will do is we will make a sketch which leaves each one of these tabs, then do an extruded cut down into the part. And those dimensions can be found here. We can see that each one of these tabs here are 60 millimeters wide, separated by 28 millimeters in between, as is for the other side. This is symmetrical. And then we see that these tabs from the edge of one to the edge of the other are 66 millimeters wide. And the only other piece of information that we need is the fact that this deeper cut through the middle is 24 millimeters wide. So with that information, let's go ahead and get into a drawing on the top plane, and excuse me, we will start with drawing the tabs on the sides here. So I'm actually going to switch to a corner rectangle so that I may start with one corner along this edge, and these slots are 60 millimeters long. They are 28 millimeters apart, so 14 millimeters from the center. And lastly, we can see that they are 30 millimeters deep, I believe, if we take a look. Yes, we see they are 30 millimeters deep. So we have that. And another thing, we want to go ahead and draw a center rectangle here out and make it the same dimensions as our original part. This will allow us to leave these rectangles instead of cutting them away. So let's then go ahead and draw two center lines with which to mirror entities about. So if we select these, mirror them over here, and then we can once again select all of this, mirror it across. We now have all four of the larger slots. Alright, next what we need to do is create the center slots here. So if we take a center rectangle, go all the way down, and make that rectangle 66 millimeters wide, and then lastly all we have to account for is each of these slots here. So if we just draw a line across there, come down here, should allow us to create a line tangent to here. If it's not, there to there. Alright, and we can trim entities here. Let's go ahead. Alright, and we can do is we can mirror this and this across here. We can then trim out these two lines. Alright, now all that's left to do is to come out, do an extruded cut, these two bodies. Notice that they are 6 millimeters deep according to the drawings. So now the last thing we have to do is make the main slot down the center, and then we will be ready to create holes. Actually, we missed one line here, so let's go back into our cut extrude, edit our sketch, and make sure that we trim this here. Alright, now that we have done that, let's exit the sketch, and it will rebuild to be correct. So let's draw that last slot, which we noticed was 24 millimeters wide. And instead of being 6 millimeters deep, it will be 12 millimeters deep. Alright, there it is. This part is coming together quite nicely. So all that we have left to do now is to create each of the holes in the top. We notice that these holes are centered on each one of these tabs, and that they are 36 millimeters apart here and 132 millimeters apart here for the larger tabs. So we will create a sketch on the top plane. That was actually on the incorrect plane, so let's exit that. Do a sketch here once again. Go to a top view, and we can go ahead and lay out our two circles here. And these circles are going to be 6 millimeters in diameter. They were 36 millimeters apart, and 132 divided by 2 millimeters from the center. So once again, take our center lines here, and we can select these two entities and mirror them across here. We can then take and select all 4 of these and mirror them across here. Alright, very good. Now all we have to do is create the holes in the centers of each of these tabs. So to get these holes into the center tabs, all we have to do is center each one of the holes onto each one of the individual tabs, and we see that they are also 6 millimeters in diameter. So let's begin by drawing one 6 millimeter circle here. And we notice that this overall gap was 66 millimeters. This gap in the middle is 24, which means that this was 33 minus 12, which gives us 21 millimeters wide for each one of these tabs. So if we offset the circle by 21 divided by 2 from one of the sides, it will be in the center. And we can do the same thing up here. Actually, we can just align the circle up with the one below it. Tell it 6 millimeters in diameter. And also tell it that it is, I believe, 9 millimeters from the edge. We'll center it because this is an 18 millimeter wide tab here. So we shall do the same thing on the lower portion of the part. 6 millimeter diameter. And it is 9 millimeters from the edge. Lastly, we will use our Mirror Entities tool. Select these 3 components and mirror them across the center line. Alright, now that we are done, we will do an extruded cut down, and this cut 14 millimeters deep. I do believe, yes, because each one of those holes are to penetrate the top portion of the part and go into these tabs, and as we see, they do. So there it is. The base is now complete. We can pull it up next to it. In fact, just check. It does indeed look similar. So all we need to do now is set the material type, which these materials were done in Autodesk Inventor, and it is simply labeled as steel. Unfortunately, in Solidworks, there are many different types of steel. If we go to the material list, we will in fact see that there are dozens and dozens of different types of steel. So I'm not sure which one is the correct one, but I will get into contact with the administrators of Inventor Wizard and attempt to find out which steel this is supposed to be, and I will be sure to pass that information along to you guys. But for now, just select any type of steel and apply that as the part material. So that part was very intricate and took up much more time than I expected it to. However, it developed many useful skills such as mirroring features across planes and mirroring sketches across lines, and other different things such as sketch fillets and sketch chamfers and other things like this. So this part was the most intricate part involved in this assembly. So all the parts after this will be more elementary and it will be more so repetition. But if you were able to get through this one, just know that you will be able to get through the rest of the series with ease. So, thank you guys for watching. Please hit the like button. Subscribe if you would like to be notified when the next tutorial video comes out. And be sure to follow the series along, and we will be assembling the model steam engine as soon as possible. Thank you.